Today's project is the console that, for me, started it all. The original front-loading NES. And this is actually the specific NES that I grew up with. I got this as a birthday present. I don't even want to think about what age that was, but this has been with me ever since, and as far as I know, it still actually works. But as you may have seen in a few of my other videos, I like to modernize and give a facelift to my own, the consoles that mean a lot to me, like I did the Super Nintendo previously. We got a fancy new case and a recapping, all the good stuff, stickers. We're going to do the same for this guy. We've got this fancy reproduction case. Plastic, well, obviously it's plastic. Translucent, smoke gray. Should look really quite cool when we're done. Along the way, we're going to recap it because it's old, and every old console needs that at the minimum. But we're also going to install a Super Nintendo Multi-out and the latest version of the NES RGB board, which gives it much more modern output capability. This thing only has RF modulator and RCA on the default unit. So there's quite a few aspects to this install. Let's get started. So step number one, of course, is open this guy up. Not a whole lot to say about that, so we'll probably just give you some cool fast forward music here, courtesy of a good friend made it for the channel. And normally you could leave all this stuff in here, but since I'm going to be case swapping, I may as well remove the controller ports and the power reset buttons. I apologize for the audio in the first section. I forgot the mic like a dummy. So hopefully I won't do that again today. Anyway, here's the disassembled Nintendo motherboard. One thing that may not be obvious is that the cartridge slot header here actually does come off. It's just an edge connector. So we're going to do that to keep it out of the way. We can maybe clean up these pins while we're in here. By the way, I was looking into it, and obviously this is the most notorious aspect of the especially the front-loading NES. But there doesn't seem to be a good solution to replacing this. There are remanufactured new slots, but from what I hear, they're all pretty terrible. There was one I saw a Kickstarter for called, I think, Blinking Light Win or something along those lines. It had mixed reviews. Some people said it was great. Some people said it was terrible. It had a deft grip that they needed pliers to get the cartridge back out from. I think it was improved after its initial run. Problem is, they don't make it anymore. And I can't seem to find anything suitable as a replacement. So we're going to do our best to clean up this existing one and make do with it, because I don't see any other options. But anyway, mainly what we're going to be doing here is removing the PPU, which is this guy here, and we're going to be installing where did I put it? Here it is. We're going to be installing the NES RGB board as an interposing layer. So essentially, you remove this, you attach this where the PPU was, you attach the PPU here, and then this takes over several of the features and functions of the PPU with new, fancier, modern versions with the jitter and all that sort of good stuff. It also has a way to do in-game resets via the controller, and as well as changing the palette that's used. Those features are, I believe, new to the 4.x version of this board. They used to be achievable via extra parts. And then we're going to install a SNES Multi-out using this very nifty 3D printed part by Greg Collins of Laser Bear Industries. And we're going to do it using Voultar's quick flex board, which lets us connect the multi-out via a ribbon cable, which is much nicer and more elegant than running a lot of wires around. We'll still have to do some wires, but this will cut out on a great deal of them. But before any of that, we're going to recap this with a cap kit I got from Console 5. Console 5 has cap kits for nearly everything retro gaming, and they're always quick to ship and real good stuff, and I'm not sponsored in any way to say that. We're going to keep this unit, unlike, say, the triple bypass where we remove the RF components. I'm going to leave them here because this is also the power board for this system. So one reason I mention all of that up front is before we do the recap, you may notice that when this is installed notch to notch, and about here, it's going to knock into these capacitors. The solution, of course, is just to have them lay down, but it's really a good idea to keep that in mind when we're doing the recap in the first place, so we don't have to go back and fix them later. So when we install the new caps there, we will lay these down to make room for this board. This is why I always like to understand my steps ahead of time, and for when I'm doing multiple things into one project, because you can save yourself some time if you scout ahead, so to speak. So without further ado, let's get started on the caps. There aren't very many on this system, so it shouldn't be too hard to keep track of. the bottom of this board just, you know, the shield just pops right off. No tools needed or anything. As far as I know, there's just the one big cap in there. So I did some checking on the Console 5 wiki, and turns out that most of the capacitors are in fact inside here. And while I said that the bottom comes off easily with no soldering required, and that's true, none of the capacitors are available on the bottom. So we're going to have to remove this from the board just to put it back later. These are particularly large. Take a look at that. Anchor points and pins. So might be a little bit of a challenge. It might even be a good idea. Well, first I should clean this because it looks filthy before I start heating solder into it. Just get rid of the dust of age. I'm going to try a larger tip and hope it's large enough on my Hakko, because if not, I think this is going to be quite the pain. And indeed, it doesn't appear to be large enough. Do I have any others? It appears I do not. So, what do we do? Gonna have to do it the old-fashioned way with wick and such, I suppose. I think that's going to be considerably harder to do, though. Let's see if I can at least get off these anchor points. Goodness, even this is too large, I think. Well, that's not going to be a lot of fun. Okay, we're going to have to do this the old-fashioned way, I guess. Maybe we just use this as a glorified solder sucker. Okay, I'm going to use a nice chunky tip for this because there's going to be looks like this thing can take a lot of heat. I don't have a lot of luck with the manual solder suckers. I find them to be quite frustrating. Don't really recommend swooping hands like that with hot tools, but you know. And I've got the cords tangled too, to show what a galaxy brain idea this is. Okay. Those contacts look decent. Let's try these anchors. And I guess now we try the pins, and we'll see where we are. last swap here. Just to get us another angle. Well, I don't know if that worked, but we sure sucked up a huge chunk of solder in the gun. Let's see where we're at. Okay, we're still adhered a bit. So we might need to finish this up with braid. Seems we've got all the anchor points freed and just these signal pins are being the stubborn. Okay, finally that guy came out. That was pretty tough, I gotta admit. Have to be gentle too, because you don't want to rip the via's top off. Now we can get at the capacitors that we were after. They're still going to be a little bit of a pain because I don't think we can further disassemble this to get better, clearer access to it, but should be workable. So, back to where we started. Now we can do the straightforward task of replacing capacitors. I'm just going to do them one at a time, I think. Okay, let's start with the big guy. Get him out of the way because he blocks access to all these others, right? And it's easy to remember where the big guy went. All right. Now I'm going to do this guy in the corner. Careful because he's extremely close to a, I think that's a capacitor. On the bottom. Okay. This is a 100 microfarad 10 volt. $16 volt, probably fine, but let's see if there's one that's closer. One. It's most likely this one. You can go higher in the voltage rating again, just as long as you meet the minimum capacitance. But if they were to have given me one that matches exactly, I'd rather use that, because it might be that this one is meant for some other purpose. 25 volt. And what are these? 35 volt, 10. So this looks like the right one. Negative leg is marked by this white part on the board, if we hadn't paid attention earlier. And I'm just going to fold it in for now. I'll probably do all the soldering of them at once. I'll go for this guy next, which looks like these 2 pins. We press it over and give it a good wiggle to, you can feel it feel free. Give it a second for the heat transfer. And then sometimes if the legs are a little bit bent, you have to work it out gently. If it takes too much force or it's not rocking freely, you probably need to clear more solder. Now see, this one is 100 microfarad and 16 volt, which is what we just put in the other spot. Aha, I missed this guy before. This one is 10 volt 100, and that's what we pulled out of the first one, isn't it? Yes. So, see? I made a mistake here. This one is better suited for the one that we removed just now. And this little stubby guy is better suited for the first one. Not a big deal. So these are both 100 microfarad. They only differ in the voltage they can accept at maximum. And then we've got a third one underneath this, I don't know what you want to call it, a bar, let's say. Rock it around until it moves freely. Since it's under this bar, it's a little hard to feel if it's particularly free, but I think it's all right. It's also hard to pull on. You can feel the pins rocking on this side, so I think it's just a matter of coaxing it out. Sorry, there's not much to see. Just trying to convince this guy he wants to leave. That pin might not be clear enough. Oh. Indeed it wasn't. As soon as it touched heat, the capacitor escaped to Narnia. I did clean the gun just before this, so it shouldn't be clogged yet. Oh, so I needed to see the rating on this guy is 10 microfarad, 16 volt. Now, Console 5 does have a map of these capacitors in case you forgot to look and then lost track of where you put it. So, not a big deal. That's a 50 volts. Oh, what's the capacitance? 51? No, that's not it. .2. Nope. $35.10. So these will work. Double check that there isn't a better one. Key thing is we want 10 capacitance. Okay, I believe it's these because these are the only thing in the 10 range. Gotta get back underneath this bar, but that's not a big deal. And there we are. Pull it through. Get it as straight as you can. It's not actually important. And then the last one is the big guy, and there's no mistaking that. Now, I mean, you can't necessarily match these size for size. I don't know if you, like, this guy is short and squat, but its original was about the same shape as this. But sometimes there's just no mistaking. All right, time to solder them back. Yeah. Believe it or not, whatever the heck that is, was there to begin with. Sorry for the awkwardness here. It's a strange angle. I'd worry more about that, but almost looks like a like, what is all this mess? It looks like these things are, I guess they're on the same traces, so it doesn't really matter, but it looks horrible. But it looks horrible out of the factory, so I guess it must supposed to be that way. Okay. Oh, that's not something we want. Get this guy done. We'll come back to that. This one has big, thick legs, befitting its gigantic size. Sorry, it keeps moving. Okay, that looks pretty good. Let's just worry about that. I couldn't tell if that was bridged to start with or not, but let's assume it wasn't, because that is a nasty looking mess. I'm gonna cut these. Cut these off first. It looks like those might be on the same trace anyway, but I can't tell for sure, so I need to clean that up to be safe. Okay, I reviewed the tape, and these did appear to be connected before. So I guess they're supposed to be. Let's just make this look a little better. Maybe a little flux. My preference would just be able to let the mask do the job, though. Like if the traces are supposed to be connected, just let the traces do it. These things look really sloppy. Like, look at that. It's really weird to see this on in that. I feel like it's really strange to see a board from the factory look like this. But what can you do, huh? Maybe Nintendo knows something we don't. Let's clean this up a little. Got a lot of flux on here that wasn't even me. We can close this back up now. Yeah, that's what it was. Okay, and with that, we're done for now with the power component. I'm going to leave it detached from the main board for now, though, just because it will make things easier to work with. Now, there's only 3 caps on here. Those should be real simple. There's one here. Not really sure how to let you see this very well. You know what? My gun is clogged or something. That's why I'm not getting great clearance right now. Let me go clean out the gun and I'll be back. So somehow that nozzle is clogged and it won't clear out easily, so I switched to the slightly larger one to keep going for now. It should be fine. And I'll look into that on my own time. That's much better. There we go. As nice as the gun is, you really, really need to keep it in good condition. Cleaning out the capture area routinely. This is a 1 microfarad 50 volt, and so is this. So seems like picked up the right replacement on the first try. Negative and positive are marked, and they were correct. So we put that on, fold these over a bit. Now remember, at the beginning of the video I said these two have to be folded down. So we're going to take them out one at a time, but we'll keep that in mind when we put them back. This is a 100 microfarad, 6.3 volt. $125. I guess this is the best match. The voltage rating is much higher, but that's okay. We're going to have some leftover caps. Because they're included for different makes or models of power supply that the front loader might have. That is okay. So positive leg is in the front. Looks like there's some solder left on this side. We'll just clean that up real quick to make it easier to put it in. There we go. And we want to be able to lay it down. So I think probably something like that is good. Although maybe what we should do is fold it more over the other way so that there's room for this guy to lay down. Yeah, I think that's what we're going to do. And this is a 50 volt, 2.2 microfarad. I got the volts and the farads right in that other one, right? Yeah. Okay. 2.2 microfarad. That's an interesting number. That says 1 microfarad. $50 volt 1. $10. I don't see any 2.2s. Let me see what the wiki says. Okay, so check the wiki. The rating is correct. There's no notes in the kit about using a less capacitive one. You generally can't replace these with a less capacitive version. And I tested with the meter and found that this is accurately 2.4 capacitance. So I think I have to put it back. It's not blown or damaged, but I don't have a suitable replacement. I either somehow misplaced the one that came in the kit, or there wasn't one in the kit, so I'll have to get in touch with them. For now, it's okay. I'll put it back. No big deal. We'll just have to make sure it's folded over. And since it doesn't have long legs, it's going to be a little harder to tack in than usual, because I have to hold it in place, but not a big deal. That'll hold it. Let me switch back to the microscope so you can actually see something. Okay, so that's where I was working. We've got an ugly joint there because I was just getting it in position. Sorry, it's hard to focus because the board is on an angle. Okay. Just use a touch of flux here. All right, and the last one. Okay, and that should be the caps taken care of. Next step is going to be removing the PPU, which is labeled on the board in case you aren't sure, because it looks very much like the CPU. And then on the back, fairly identifiable 2 rows of pins here that we're going to be taking care of. What we're going to do here is desolder all these pins, but I'm not going to go straight at it with the desoldering gun yet. The PPU and its mounting pads we want to treat a little carefully. So the first thing we're going to do is add some leaded solder to it. The leaded solder melts at a lower temperature. Well, I can't say for certain that they didn't use leaded here. I don't actually know when that's changed over, but regardless, the solder I have here will melt at a lower temperature and it'll be consistent. You normally don't want to mix unknown formulas together. It can make for some poor joints. But in this case, we're trying to remove it all anyway. Letting the fresh solder soak in will just make it easier for the gun to do its job. So we're gonna just start by loading up the tip here. And we're just gonna go along slowly so it can melt and mix in. So no need to rush. It's better that it soak in through the hole. Okay, it's probably pretty good. We'll use some flux to prevent that kind of weird spiking later, but it doesn't matter right now. Sorry, show you the right place. That's what we did, and this is where we are. When you're just installing the NES RGB, getting the PPU out part is considered to be the hard part. It's probably pretty good. And this is going to be extremely boring with very little to see, but we're going to do the usual, cover each point, wiggle it around, and evacuate the solder. All right, now that that's done, we're gonna go check that each of the pins is free. Gently, we should use a more suitable tweezer. I'll just use a spudger. Gently, oops, trying to just rock them and make sure that they seem free. Didn't need to actually. You can shine light through this too, like use your phone's flashlight function and see, can you see through the holes? You can see how clean these look to be, so I think we're going to be good. but sometimes you get a teeny little bit of solder just hanging on, and rocking the pins like this can help break it up. So it's a nice thing to do. Okay, that looks pretty good to me. Let me try and show you what I meant about shining a light. Here's the PPU, there's a light. You can see how can you see? There, I guess like that. You can sort of see how the light comes through the holes, whereas not so much here. You can use that to figure out if any are still clogged. Trust me, it looks more illuminating in person. I need a camera that focuses and zooms properly, but I can't afford that right now. Anyway, you don't want to force this guy out. If it's not ready to come, keep working at it until it is. When it is ready to come, there, see, it should lift out pretty nicely. And you want to lift it from both sides so you don't bend some of the rear pins strangely. Ugh. Got some weird solder splatter there somehow. I'm gonna clean that up with braid. The next step, and this is a little, there's some options here. Where am I? Okay, the next step is you can either directly attach pins here, as in this sort of pin, can solder them in. But what I'm going to do instead is the NES RGB kit comes with this socket. And what this lets us do is easily attach or detach the kit if we ever want to in the future without having to solder again. Or even go back to the original PPU easily if we had some reason to want to do that. I like the option, so I'm going to go ahead and solder in the socket instead of doing it directly, but it's up to you. So we're just going to tack this in. Got a little solder on my tip here. Just enough to hold it. In this corner too. Now we should be okay to finish soldering. You can drag solder this like I did when I was adding flux. adding solder rather. Let's try that. Not usually my preferred technique. I I don't know, I like to do one pin at a time normally, but why not? Let's do something different. And as long as we're steady with a good supply of fresh solder, which has flux in it, we should be okay without having to add our own flux. If we need to go back for a joint, we may have to add some. I'm not doing so much of the dragging here, it's more like this. Between paying attention for the camera and trying to position things. But yeah, that should be pretty good. And then we'll do the same for this side. And we're almost done. Good. The only thing left to do is clean this up, all the flux residue, which I will do now. And we had flux residue from the capacitors too, so I may as well get that. The toothbrush is nice for getting the flux off without leaving cotton residue like the Q-tips do. But the downside is that it has a tendency to mostly just push the flux around rather than actually clean it. You have to clean the bristles on a paper towel pretty often to remove any flux that they've absorbed. You'll see that the paper towel kind of yellows where you do that. Take a few rounds, it should get better and better. Okay, switched back to my large handles and tips for this because, well, this is a large ground plane that eats a lot of heat. And the station can do it fine, but no reason to use a micro soldering tip for a large thing like this. This is going to eat solder like crazy. Okay, and now that's in place. So our next step is going to be installing the PPU onto the NES RGB itself. So let's set this aside and take a look. We have two tasks here. We need to install the pins into this. So that would be these guys. And you can see they're the same on both sides, so there's no like up or down. They need to go in the outer row here and the inner row here. Now, one good thing, see how they can rock like back and forth? It would be very hard to solder these straight so that they will go into the socket well later on. So a good thing to do might be instead to put them into the socket first. It shouldn't take much force. It's not ziff, but it should be quite doable. So we've got one in there, and I'll put the other in. Takes a little bit of force, but it's not terrible. Kind of rock it in, and then you've got the pins installed. Now we can set this on top, and we know that the pins are going to be aligned nicely. Make sure this board sits well and is clearing anything underneath that it might need to clear, especially those capacitors that we moved earlier. Make sure they're moved enough. Seems pretty okay in this case. Okay, so we're going to go ahead and solder this in. I've switched back to my micro soldering handle again, but I want a different tip because I'm going to not drag solder this time. But you barely drag soldered last time, you say. And you were right, nonetheless. Okay. Make sure this is sitting flat, and it seems to be. I'm going to fix the focus if I can. Okay. I'm going to just do a corner here. Actually, you know what? Let me prop the board up so it's not at an angle. That way the focus won't keep failing everybody. I'm going to set it once and we should be good. Okay. Anyway. Do that corner. And that corner. Okay, does it look good? It does to me. Let's do the rest. Okay, so I said there was a reason that I was doing the top first. And that reason is we need to cut off the tops of these pins so that they're a little flat. Why? Because the PPU needs to go here and it won't sit flat. I don't know how well you can see that. Well, probably not at all because it's on the side, but it sits at an angle with the pins at full height. So in order to fix that, we're just going to go in here with flush cutters. But you can do this before or after soldering the row, honestly, but there's pros and cons. So the advantage, as I showed you, to doing it this way is that the thing is well aligned. But you get nicer solder joints if you can solder it after you've cut them. So I'm going to try and do a hybrid, I think. I'll do enough pins where it feels like I can remove the socket. I'll cut them and then I'll finish. See how that goes. That was kind of strange. Guess there was alcohol left. Okay, now let's see if we can remove the socket. Just pull it gently and steadily. It's going to be a fairly tight fit. So I'm going to put the board aside. I'm going to put on some safety glasses. And I'm going to go with flush cutters to all of these pin tops. I'm going to cover it with my hand for the most part so that these things don't shoot off somewhere. Even with the glasses, it's better to be safe. Okay, that's all done. Let's try and clean this up a little bit. Random pieces of metal and stuff. Now we've got these cut much flatter. Our PPU should be able to sit there much flatter. And it does. It's not perfect, but it's pretty good. Anyway, pin soldering. Not many left. Oh, now they're more like, oops, let's clean that tip. That's horrible. So here's another option you get. You could install another socket here so that the PPU is on a socket as well as the NES RGB itself. The kit does not include the second socket, but certainly that is an option you have. I'm not going to do that. Mostly because I don't even have the socket here, so I couldn't if I wanted to without delaying this video. But I'm not sure that it's really necessary. It's nice to be able to remove this piece itself during installation. If you think you're likely to ever want to reverse
the NES RGB, then sure, go ahead and socket it. Make your life much easier because, you know, the PPU itself can be a bear to remove. But I think it unlikely I would ever do that. So now we can install the actual PPU. Make sure it lines up nicely. It really should just kind of fit super good. You know, no forcing it at all. Then we come over to this side. Make sure everything is flat as it can be. And we're gonna tack it in. Get some solder on your tip. Good. I'm gonna do this side. Solder on the tip. Just enough to hold it. Doesn't need to be sufficient. Make sure it's aligned how you like. Now we'll solder the whole thing in. Great. That's the PPU soldered. More cleanup of flux residue. So now we have a NES RGB with PPU installed. Hooray. This is the new version, so it has a lot more jumpers. Maybe it's time to go through them. Okay, so jumper 1 is here. This controls palette selection mode. There's two ways to control the palette using, easy for me to say. There's two ways to choose the palette that the NES RGB applies at runtime. The first is with a mechanical switch. Historically, this was done by either drilling a hole in the case and putting a switch out the back, or by overriding the reset button on the front of the NES to toggle through the palettes. On this new version, instead, we can use the controller input to do the job. And so that's what I'm going to do. Jumper 1, open means use the mechanical switch, and closed means controller. So I'm going to close this jumper. Jumper 2 is which palettes are used when in mechanical switch mode. Since we're not using mechanical switch mode, doesn't apply, so I'm just going to leave it alone. 6 is for reset polarity. Open is negative, which is the right setting for Famicom and top loader NESs. Closed is positive, which is the front loader NES, like mine. So we're going to close this. It's an ugly looking blob. Doesn't matter, but I don't like it looking ugly. There we go. 10 is de-jitter timing correction. Open is standard timing, closed is de-jitter active, which is recommended. This is only applicable to NTSC consoles, which I have. So de-jitter is a little difficult to explain in a short period of time, but it prevents an effect that particularly screen capture things hate. Okay. Jumper 11 will disable the LEDs for user diagnostics, these guys. I don't see any reason to do that, so I'm going to leave it alone. Let's see what the other jumpers are. Jumper 5, at least on the older models, is what controls NTSC. Jumper 4, J5. So if you, NTSC NESs should close this. That's a pretty one. Good. And let's see. Jumper 4 and 7 are for PAL. I don't see 8 or 9 mentioned in the documentation at all. So if they're not mentioned, I'm going to ignore them. That should be the configuration done. One more thing we need to do is attach this quick solder board to these points. This is optional, but it's what gives us a nice ribbon instead of having to run wires. This is by the legendary Voultar, and it's designed specifically for the NES RGB. I am going to quickly socket this back into the system's main board to assess the clearances, though, because it looks to me like we're butting up against this, and I don't want that. So make sure all the pins are aligned correctly. Looks good. Push it in until it's seated. We don't want to keep pulling this in and out too often. So, seems really solid now. All right, so I don't know how you're supposed to mount that. If the expansion slot is in the way. So here's the problem I'm looking at. This board sits right up against the expansion slot thing. And so this barely fits it's supposed to solder like out here, but there's no room. So I'm gonna go look into see if there's recommendations about what to do with that. So strangely enough, I was unable to find an explanation of how to install this thing or how you're expected to install this thing on specifically a front loader without running into the AV socket. But the answer I think is pretty clear once I thought about it a little more, because there's these through holes here, which are equivalent to the pads. You can use either one. So what I'm going to do is, they want it mounted this way. That's the normal installation method, is to solder it to the pads like so. But what I'm going to do instead is go on the back side, put some pin headers through, and I'm going to solder it upside down to those. It'll make the same contact. The cable will be coming out in the opposite direction away from the expansion port, so it won't be in the way. And these are the equivalent pins that I want to be hitting if it were installed on the proper side. So I think that's the right solution. It does mean that I'll have to solder the audio wires to the underside of this board, which is a little more awkward, but that's not the biggest deal in the world. So we'll just try and tack it in here as nicely as possible without the aid of anything holding it for us. Get some solder there so I can hold it here. Okay, that looks decent. We'll do this side. Push up on it. Good. Now we'll go do the other pins and we should be good here. This is a castellated edge, so we don't have to make a connection to the top of the board for it to make a good connection. The gutters, so to speak, are also have contacts. There, and this is not a labeled jumper, but this needs to be shorted if our intent is to use the NES RGB's audio, which in my case, I do intend to use it, so there. And that should do it for the Voultar quick solder. I'm not sure why there aren't really instructions for this, but we're smart people, we can figure it out. And that's really what it is. I'm perfectly willing to experiment or do something that seems reasonable or viable, but I would prefer first to see if there's a recommended method before I start inventing solutions. just make sure there's no bridging that I can't see. I wouldn't expect there to be, but and then I'm going to make sure that each contact point from here shows up somewhere here. I don't know what order they're supposed to be in, but if they're connected, except for this one, then we're making good contact. Through the castellated edge. Okay, this one looks like it's not making contact. Because if I touch the thing itself, I get a beep. If I touch the pin, I don't. So we'll revisit that one. This one's obviously working. This one looks like it doesn't have a connection also. Yeah, there's nothing there on the board, so that's okay. This one has a connection on the board, but it doesn't go to the connector, so these may be the audio pins. These are probably, I mean, yeah, you can see that one. Right. So that connects to there. This connects here, so we can see the connection's fine. The connection's fine. So it was really just, is it this one? No, this one? Yeah, just this one. That's suspect. So let's touch that joint up. Get the freaking board moving. And now, do we get, yes. Okay, so looks good. So with the Voultar header attached to the NES RGB, we are mostly done with this part for now. The next phase is going to be connecting a few wires to it. But we have to do something else first. The NES RGB kit comes with this voltage regulator, and the purpose of this is to take some strain off of the onboard voltage regulator, wherever that is, because the built-in one is too small for the job and overheats and causes visual problems and other anomalies. So what we do here is we run a wire from the unregulated power to this board, and then from this board to the NES RGB to power it. Because nowadays this thing is like using an FPGA. There's probably far more processing power on this daughter board to correct the colors and artifacts and such than there is on the main system's CPU by a lot. It's weird how things work these days. So anyway, this is going to mount in the case roughly here. So we're going to take 4 wires connected, hopefully, if I can find the right sort. We're going to run 2 leads to here and 2 leads to the NES RGB. And they're going to land on these pads that we used here, these 5-volt and ground, 5-volt in one of the grounds. So what I'm going to do here is start by tinning these pads. Go. And I found length of 4 strands of wire that we're also going to pre-tin. Now this thing goes ground, voltage in, 5-volt. So we're going to be running this in 2 different pairs. 1 leg for each pair goes to ground. So in this case I'm going to do purple ground and green ground. And then we will do purple for, or sorry, blue for the voltage in, that's power from the regulator. Now, because we're trying to route cables neatly, we might want to temporarily at least mount this back in the case so we can judge the length that we're going to need properly. I think the idea is that it attaches to this. Is that right? Not sure what that screw hole is for. I mean, it has a screw hole. I'm not sure if there's some place it's designated to go or not. I don't really see anything obvious. Out of curiosity, let's see. Did it fit in the old one? No, the old one didn't even have a boss like that. So it does have an adhesive on the bottom. So I mean, we're probably just gonna stick it here. But that means that it has to run from there to here. Which puts it, what? Let's say somewhere, let's say the left half of the slot connector. If we have a little bit of extra slack on that part, I don't think anyone's going to care. It'll just give us some more flexibility for mounting it nicely. So let's say it goes like roughly here. We're going to run it up, and then it's going to come across to here. So that looks like a good length to start with.
I'll cut this out. All right, and then we need to cut off the blue and purple from the green and yellow. Because blue and purple is going here to the unregulated leg. Specifically blue on the left leg when we're looking at it from above, and purple on the middle for ground. I really wish I had an intermediate zoom for you guys from somewhere between microscope and whole desk. Okay, now let's make sure we haven't bridged them, since it takes 2 seconds to check, and we could really wreck things if we did. Looks good. And blue, may as well check this. Blue to blue, purple to purple. Okay, good. All right, that runs there. Maybe a little more slack than we'd ideally like, but it's not awful. And then we'll run this over to the triple I was about to say triple bypass. We'll run this over to the NES RGB. Got my consoles all confused now. Conveniently, the ground and 5-volt pins on here are right next to each other, so we don't need to split the wire much. And 5-volt is yellow, so yellow is going to come to here. Let's pre-tin these. I'm going to use the pads in this case. I could also use this pin, but the pads, since I didn't use them for signaling, are easily and readily available here. So let's pre-tin them. And there's our voltage regulation all done. Now, note that these are still going to bump into the expansion slot with very little clearance. Maybe you could come from the other direction, but I didn't want to try and go over these pins. You could even solder to these pins directly instead of, but I thought that might look better. We could even run this cable immediately under the board and through the little ravine left by the chip. But we're nearly done, I think, with this part. We'll need to attach the flex ribbon to here. Now try to look into the slot and see where the pins appear to be, so you know which orientation to put in the ribbon. In this case, it appears you want the pins facing up relative to the slot. Oh, you want to pull it open first too. There's little black tabs to pull on each side. Just pull them out.
If you've used a flex cable with a ZIF socket before, this is nothing special. Put it in, it feels seated well. Push the tabs in. Looks straight. Seems good. Okay, so I think the major part of this is done. What's left? Well, we still have to connect to a few points on the controller port and similar to get the on-screen, not the on-screen, to get the controller control of the palette and resetting. And we need to pull audio. But I think to do those things, we probably should finalize the board in position. So I'm going to go ahead and carefully push it in. And to make sure all the pins are lined up properly. Nothing sticking out weirdly. We're looking good. Push down firmly. Try to go in from all sides at the same time if you can. Make sure you're not pinching your power cable underneath the socket. Try to get a look to see if there's any air gaps left. Not sitting completely flat. Well, I'm going to take a look at what that might be. I am the worst with the microphone. I'm sorry. So what you probably just saw me doing was I put this on and it wasn't sitting very flat. So I looked into it a little bit and there's a few capacitors on the board that were running into the bottom. So I lifted it back off. I folded them down gently into position again, you know, so that this can fit more unencumbered. Now it's sitting pretty flat, and that's good. So what we're moving on to now is these controller inputs. So we have R0, which we need to wire to the reset pin, which is the second pin from the top on this blue port. That will allow the controller reset function to work. You can also wire this to pin 7 of the CIC chip, but I feel like this is a large and easy to access target. So we're going to start there. And that's just going to be a single wire. We don't need to do anything special, just tin both ends. Just going to go do all the pads we're going to use here. As far as I know, you don't need to use this ground for anything. It's there, if it mentions it somewhere as a convenience. Okay, that should be good. And then we need to run 3 leads to the controller input for clock, latch, and data. So a red, orange, yellow on the original port. Well, just so happens I have red and orange and yellow, and why not use them? see. A little longer than that should be enough. Just for reference, here's the controller wire. You can see, I think you can see, red, orange, and yellow are starting second from the right, which plugs in this way. Doesn't it? Yeah, plugs in this way. So we want the, from the right, we want these 3 pins, 1, 2, 3. This is going to be awkward, and this is plastic. So, you know, actually, why don't we get from the bottom instead? That should be much easier. So we want the inner 3 from the left. Clock is red as the first one. Let's give you a microscope for this, because... So I realized that the red, orange, yellow cables I cut aren't going to be long enough if I use the contacts underneath as the attachment points, which are easier to work on and don't risk melting this plastic header. So I think that's the way to go, but the extra length needed to get under there doesn't reach the board anymore. And I tried coming the other way underneath and up through around here, which would have been the perfect length, but the slot header would cut off the cable, and it's not long enough if I reroute off to the right. So unfortunately, I'm not going to be able to color match. I don't have another length of red, orange, yellow long enough. So we're going to have to substitute purple, blue, green. No big deal, but it's nice to match colors when you can. So on the upside down, we want to come from the left. So the first pin is a ground, we don't care. Second and third and fourth pins are the ones we want in order. So let's see. And I'm going to cut it about here. That'll give me some slack in case I need to reroute it when it goes in the case. And let's see here. 1D. The red wire is clock, which for me is the green wire. And the green wire has to go to the middle. Okay, so the order on the other end has nothing to do with the order on the board here. See through something. Something else. Okay, so that should be all we need for the controller inputs to control the board. So what remains? Just audio. Audio comes off of pins 1 and 2 of the CPU, which is over here. But instead of soldering directly to the CPU pins, I'm going to instead solder to these legs of these resistors, because you can see they're connected, so same thing. And it's easier to get at the legs. So I'm gonna pull this back off. Okay, so maybe you were yelling at me before, but I realized that the A and B pads on the front of the NESRGB are the exact same pads passing through to the Voultar board. In other words, this pad, this pin, the board underneath, and the audio wiring points on that board are all the same thing. So I don't need to get at the Voultar board to attach the audio after all. I can just attach it to this side, which is what I'm going to do. Obvious in retrospect, as many things can be. Of course, it's going to be a little cramped to do that with this expansion port here, but we'll make do. I need someone looking over my shoulder to make sure I'm not doing dumb things so that you can't see what I'm doing. We don't want to touch this plastic part if at all avoidable. But all we need is the A and B pads. Blurry as heck, sorry. There. A and B pads. And we'll do our darndest to get this wire in there straight. Actually, let's do the orange one first, since it's furthest from my right hand. And yes, we're going to be bending this a bit. That looks pretty good. Yeah, let's go with that. Looks good. We need to get that one in position. Similar bend would be good. This might be better with tweezers. Okay. Now we connect those to the CPU pins, or more conveniently to the resistors here. Pin 1 of the CPU here is resistor 4 here, and that goes to A on the board, which we made orange. A is for orange, as we all know. Let's add a little bit of fresh flux to the base of those resistors instead of 30-year-old flux. Double check. Orange on pin 1 to A on the board. All right, so we've got audio. We've got power. And we've got the board installed with the PPU. We're really close to being able to test this guy. SNES Multi-out header. This is where the other end of the ribbon will go. And this will get installed into our beautiful Laser Bear SNES Multi-out header. which I'm having a hard time finding because it's transparent. There we go. Into this. The notch, let's get this out of the way. The notch is the top, and the flex cable header is on the top, I'm pretty sure. If we get this wrong, it's not the end of the world. It comes back out again. But anyway, you slide this in. It even says this side down. All we have to do is slide that in and use the included screw. Okay. Why did the lights just turn off? That was weird. Use the included screw to lock it into position. There we go. And that's ready to go. So what do we need to do to test this? Not much, but the NES is a bit of an odd duck. What do I mean by that? I mean, to attach a cartridge, we have to reinstall this cartridge header. Why do my lights keep turning off? We need to install the cartridge header and the stupid loader mechanism. And to do all of that, you kind of have to put it in the case. So, therefore, we're going to have to put off testing for a little while because we need to move on to more physical concerns. What on earth does that mean? What do I mean by the more physical aspects? Well, we want to install a NES Multi-out, but of course the NES didn't originally have such a multi-out. Obviously, right? But that means it needs somewhere to go in the case. On a normal case, this would be something of a problem because there's nowhere to put it. Let me show you. Right? So they've got this guide here. You attach the outside position where you like. Then you would draw here the outline of the port you need, and then you would drill it out, use a Dremel, etc., etc. As I'm speaking to you, though, I realize I didn't even know this case appears to already have a space for a multi-out to go. That is kind of amazing. I had no idea. So that will make life altogether easier because we can just mount it right here. I'm almost certain that's exactly what that's for. So then, if we just go at these little tabs with flesh cutters, and if the poltergeist would stop turning my lights off, what could be more annoying than your lights going off while you're working? Maybe it'd be better if I just dremeled that out instead of using these less than elegant flush cutters. Let's get an actual Dremel to do a Dremel's job, and I bet this goes pretty quick. And that is pretty awesome. I'm just going to file down the burrs a little bit with a hand file. Doesn't need to be perfect, but I think that looks really good. And I say it doesn't need to look perfect, not because I'm willing to put up with problems, but because it's going to get covered up by the connector anyway past this point. So now all you got to do is mount the connector, and that's easily done. Just feed this in. Oh no, is the laser bear? It is just a touch too big for this hole. I wonder what they were targeting with this. Well, that's a bummer. Well, that and the screw I shouldn't have put in until after. Apparently, the screw is supposed to go in after you put the port in the case. I don't think that's what's stopping me from inserting this, though. No. I mean, it was a thing stopping me, but it's also slightly not wide enough. Well, then we just file it away until it is wide enough. Still, this hole gives us a good head start on tedious work. So, even if it's not perfect, I appreciate it. I'm going to cut most of this, but basically what you do is you file, you file, you file, you test. Are we there yet? No. File some more. Because you can keep taking material away, but you can never add any new material back. Once it's gone, it's gone. So overshooting is your worst enemy. And there we go. It went in. Nice. Clean off a little dust. So didn't take all that much filing at all, really. Just had to widen it slightly. And then it went in pretty nicely. That is a great feature of this case that I did not know about and was not expecting. And even if it's not perfectly sized for the Greg Collins laser bear mount, it's still a heck of a lot of a head start and a nicer finish than you would have if you had to manually drill the whole hole. Now, to anchor it inside, we slide this retaining clip around the port. So it should just click in. And then we put the screw that I took out back in to hold the electronic part in place. And now we are ready to start reassembling to some degree. we can start with case basics like, oh yeah, he's going from the front, like the controller ports and the original's controller port header, because this does not have a replacement for that. These may look identical, but they aren't. The player one has a slightly longer wire because it has to reach a little further. But they kind of just sit here in the front, like so. And then this piece is what locks them in, like so. And then it had two screws. Okay, it's the next day, and I came back to this. What I've done is disassembled what we had yesterday and kind of did a hacky install here just to get all the cables to connect so we could test this thing. But it looks like a mess in my overhead cam, so I'm going to hold it by hand to show you around. I apologize if it ends up looking really shaky. I'll do my best. One of these days, when I can afford to, I will get a better camera situation, I promise. Okay, so let me take this down. Here is the NES, where I've got the board upside down, at least upside down for how it's meant to sit in the case. This is so we could see the NES RGB, which has LED indicators here that we might want to see. In particular, what I wanted to check is that LED 7. I can't make this focus that well, but the LED on the end is supposed to light up if it detects that this capacitor is insufficient or marginal. So I decided not to replace that capacitor unless that happens, so I want to make sure. But otherwise, this is sitting as it should be. I've got the signal cable into the case because I didn't want to take this back out and risk messing up that slot or hole in the case. The regulator is just kind of hanging out here where it's not going to touch anything it shouldn't be touching. Got the controller ports just hanging off. They probably aren't necessary to just do a test boot. And then I've got the cartridge slot attached with the motherboard sitting on top of the game. Not really the prescribed manner for doing this, but all we need now is a signal cable. When I've got a Super Nintendo style here, plug it in the back, and then power. I don't have an original adapter, but I do have a Sony PlayStation Slim adapter, and I made a bunch of adapter cables for it. This one fits the NES. It does a polarity swap. This is sort of a tangent. The center is positive on that. The center is negative on an original NES plug. Although, interesting trivia about the NES is that it has a full rectifier in the power supply, so it can actually handle either polarity and including AC. It's weird like that. So in this case, not super important that we get the polarity right. But anyway, moment of truth, I suppose. Let me turn on that, and I'll position here so we can see the LEDs and see what happens. Fingers crossed. Beautiful. Sorry if you had an echo there for a minute. I forgot that I had my local speaker on, so my mic was picking up the same as the capture. Anyway, this is looking great, and you can see the only LED on is number 1, and that just tells us that palette number 1 is selected, which is, I'm sure, the default, so that makes perfect sense. 7 is not on or even flickering, so hey, that's looking good. I'm gonna turn this off before YouTube gets angry. So what's left? Not a whole lot. I think I need to try and do some serious cleaning on the cartridge slot and connector while I'm in here. Metroid booted up just fine, but with a little more testing, I found that it's a NES, you know, it's real flaky. You can move it a fraction of a millimeter and suddenly you get a scrambled screen. I'm gonna do what I can. I'm not sure how much that's gonna be, but then it's going to be assembly and I can show you the final completed project. So as I'm reassembling this, I don't have all that much that's interesting to say. It's a fairly simple assembly, just as it was a fairly simple disassembly. The only trick I would say is that you want to make sure the ribbon cable for the output port doesn't go anywhere that it might interfere with a screw hole. The voltage regulator, I chose to stick to the case on the bottom here, right underneath where a sticker goes, so you won't be able to see the ugly sticker side through the case. Just an aesthetic consideration. It can go almost anywhere, and this case is full of empty space, so it's really, really easy to decide on where you want to put it. It has a screw hole in it, which implies to me that they intended for it to go some particular place. But even looking at the screw bosses in the original case closer again, I don't really see where they intended for that to be. Again, I don't think it matters at all, so I'm not going to lose any sleep over it. And it's fine where it is. So I'm going to continue forward, and if I think of anything else, I'll let you know. But otherwise, I'm going to finish this up and show you the final. Fully assembled, and man, I could not be happier with this case. It is beautiful. Pull that for now. Let me give you a look around. We've got the front lettering. This was from an Etsy seller I've used before in my Super Nintendo video. I think that really gives it some pop. Really cool. I chose not to put in the gray cover that originally came here from my original because it looks nicer and clear when you can see all the guts. I have reproduction stickers with a slight rainbow sheen to them. I forget the term for that, but and sides. And the rear, where we've got all the original ports and the new port, which even looks cool. But, of course, how does it work? How does it play? Let's make sure it still does. And this time I've got a controller. If I had a small nitpick, it's that this door has no mechanism to hold it up. It just kind of flops. Very, very minor thing, but if they wanted to improve anything, I would suggest that. So I had Metroid out. Let's see if we get lucky and get it to boot on the first try. And get up the capture for you. Perfect. I cleaned the heck. Sorry about the echo again, and I keep forgetting. I can't hear the echo locally. I just have to realize it when the mic input is going nuts and I'm not talking. Anyway, first boot, perfect. Can't ask for more than that, right? I cleaned the heck out of the edge connector on the motherboard and the slots themselves, both scrubbing thoroughly with isopropyl, but also using some contact cleaner, generously applied. The feel of the slot is still pretty good for all this time. Let's try another game. First boot. And I'm going to demonstrate some of the things you can do. Oh, what was that? Maybe just have to... It's still a NES after all. So we can do an in-game reset by A, B, start, select at the same time. Reboots. And I don't want to hear anyone out there making fun of my B-shoe zipper. You might think this is the ultimate Player 2 controller, but they were cheap and they worked real well, and I went through a lot of these as a kid. The turbo function was aces. But the one other thing I wanted to show you is palette selection. So I'm not sure how readily apparent this will be when I show it on here, but the Retro RGB has a bunch of different palettes you can choose from, and this is the default one. If you hold in Start, Select, and press right, you can change to one of the other 6 palettes. Which one you use is totally up to you. It might make a bigger difference in some games than others. Some of them look cooler. And when we say palette, we mean like the tone of the colors specifically, not which colors it's choosing. So, and if you hold in right for 2 seconds, it goes back to the default. And that's it. I hope you enjoyed that. I had some fun doing it. It was nice to give such attention to my own console, my own childhood console, my very first console. I spent so many hours on this thing. Along with the Super Nintendo, they've both now gotten their moment in the sun. This was a very nice mod. That NES RGB Kit is really well done. It's not terribly hard to install. The Voultar kit definitely makes it easier. I'm not really a fan of doing things the hard way if you don't have to. I mean, we all know we're capable of running more wires, right? And but why, if you can just use a flex cable? Much easier to work with, much easier to install. I prefer that. If you can afford to do it, and I mean, this is hobby stuff anyway, right? Then I would say go for it. There's other things you could do to the NES. We could replace the CIC chip, which is the lockout chip that causes it to blink reset when the cartridge has a bad read, as well as prevents it from running bootleg games, or at least that's the intent of it. You can cut the leg of it to disable the reset functionality, which sort of neuters it, or you can replace it with a null one. May do that in the future, but for now, this is the end of the project. I'll include links below in the description to any of the products I used. Some of them may or may not be affiliate links. If you want to use an affiliate link or a coupon code listed below, that would help the channel out a lot. All this equipment and stuff is kind of on the pricey side. But anyway, thank you for watching, and we'll do something different next time.